Alright, so let's go over some homework from sections 1.4 and 1.5. Bring up my draw here. Okay. First one that I'm going to do from section 1.4 is number 27. So in number 27, it says, discuss the continuity of each function. So our function f of x is equal to 1 over x squared minus 4. So we have a rational function. It's built of two polynomials, right? Well, actually, it's a constant over a polynomial, but all constants themselves are polynomials. So we know that this is going to be continuous everywhere except for when the denominator is equal to 0. So if that's true, let's try to figure out where the denominator is equal to 0. We can factor x squared minus 4 into the quantity of x plus 2 and x minus 2. So clearly, the denominator will be equal to 0 when either one of these two factors are equal to 0, and it is equal to 0 whenever x is equal to negative 2 or whenever x is equal to positive 2. So then clearly the limits can't exist at those points, so that means that we have discontinuities at x equals plus 2 and x equals minus 2. Matter of fact, those are where our vertical asymptotes are. We can go a step further and discuss what the limits are on the left and right of each one of our vertical asymptotes, whether or not it goes to plus infinity or to negative infinity. So we could say, well, since f of x is never equal to 0 in the numerator, because our numerator is never equal to 0, then one moment. Alright, sorry about that. Had something. So, we can split this up into regions, okay? Separated by the vertical asymptotes. So, to the left of negative 2, we can say that since the function is continuous, everywhere else besides negative 2 and positive 2, that means for every value less than 2 it's continuous, and the function never equals 0, so therefore it always is either going to be either positive or negative, because it can't cross the x-axis. So we choose the test point in this first region, and that test point for us will be negative 3. Negative 3 plus 2 is going to be a negative value. Negative 3 minus 2 is going to be a negative value. So we get a positive value, so that means that it's going to diverge to positive infinity, because it diverges to infinity first of all, and it has to be some kind of positive value, so therefore, as it approaches to negative 2 on the left, it will diverge to positive infinity. So, in our second region, we choose a test point of 0, and 0 plus 2 is 2, so that's a positive value, and 0 minus 2 is a negative. So we have 1 over a positive times a negative, so that gives us a negative value. So that means that all of the values between negative 2 and positive 2 of the function have to be negative. Therefore, we can say that as x approaches values to the right of negative 2, we get divergence to negative infinity, and as it approaches the left of positive 2, we get divergence to negative infinity. On the right, we choose a test point of x equal to 3. So at 3, we have 3 plus 2, which is 5, so that's positive, and 3 minus 2, which is also positive. So therefore, every value must also be positive, and therefore, as the function approaches 2 on the right of 2, or from the right, then we'll get divergence to positive infinity. So that's number 27. Next on the list, not in order, is number 83. And in number 83 it says, in exercises 83 to 86, explain why the function has a 0 in the given interval. Well, they give us a closed interval of 1 to 2 and a function 1 over 12 x to a fourth minus x cubed plus 4. This is a continuous function because it's a polynomial, and all polynomials are continuous. If we evaluate it at its endpoints, so at the endpoints of this closed interval that they specify for us, we get f of 1, which is going to be, we can just replace all of these x's to a certain power with 1. We'll get 1/12 minus 1 plus 4. This minus 1 and plus 4 become plus 3, so therefore 3 plus some positive number is going to be another positive number. So at f of 1, or at x equal to 1, our function is positive. At f equal to 2, we get 1/12 times 2 to a fourth minus 8 plus 4. The minus 8 and plus 4 become minus 4. 12 is the same thing as 3 times 4, which is, and 4 is 2 squared, so we can cancel out 2 exponents up here, right? And that gives us 4 over 3, so this is slightly greater than 1, and so this is 1.3 repeating, and we have negative 4, so negative 4 is greater in magnitude than 4/3, so it's more negative than it is positive, so therefore I'm going to get a negative value. So by the intermediate value theorem, we have a continuous function on a closed interval where the function evaluated at its endpoints is opposite in sign. So therefore, I have some kind of continuous function. It starts off being a positive value, and it ends up being a negative value on a closed interval. And if it's continuous, that means that if I start at my positive value, I have to cross the x-axis at least one point between the endpoints of my interval. So therefore, that I can say that there's a root somewhere between 1 and 2. Okay, and that's number 83. And we're going to break it up right here. We'll continue on with number 47 in the next video.